I'm pretty excited to be here with you guys because I know fourth grade at Bridgeport is amazing, and we've been studying all types of forms of energy. So, every time I do a science show, it's like, it has to be sponsored by somebody or something. And today's show is no different. Today's show is sponsored by my sponsor, the sun.
What?
Oh yes, brought to you today by the sun. Because without the sun, most life as we know it, and energy as we know it, would not happen. But thanks to the sun, which is 92 or 93 million miles from us, this giant burning ball of gases, of hydrogen colliding, we get the energy here on Earth. In fact, the sun, if the sun was 6 feet in diameter, like my outstretched arms, the Earth is about the size of this cat compared to the sun. So that's a lot of energy. Talk about forms of energy. All the trees that have burned, all the cars, all the coal, all the gas, all the power plants we've ever had in the world are less energy than the amount of sunlight that hits the Earth every day. You can't even think about that. I can't even understand that. So here's the deal. You kids, I'm getting old. And when I get old, I don't want to sit somewhere dark and cold. I want energy. So you need to find ways to not create, not destroy, but to transfer energy. In fact, you can't create, you can't destroy, you can only transfer energy. Say that again. You cannot create, you cannot destroy, you can only transfer. So I want you to find ways to transfer energy from the sun so I can sit back and enjoy life. In fact, I did that this morning. I had some chemical energy. Now on your worksheet, I have different examples. I have thermal energy, electrical energy, sound energy, light energy. Repeat after me. Potential energy, gravitational energy. Potential energy, chemical energy. Potential energy, elastic energy. And finally,
Kinetic energy.
Connecticut, that's the state out by New York. You say Connecticut energy?
Kinetic.
Oh, kinetic energy. Okay. Here is some potential chemical energy. Oats. No, seriously. The sun shone down. Oats grew in Iowa. The energy was soaked up from the sun in these oats. They were cut, put in this box. I ate this morning for breakfast. That chemical energy from the sugar that came from the sun is in my belly. It's being converted to sound energy, to mechanical energy, and a little bit of heat energy. I converted this, and because of that, we have transferred one form to another. So you want to draw an example of potential chemical energy? A box of oats. In fact, we have a lot of different examples here. So your job today is to kind of come up with some examples of thermal energy. Here's a hard question for you. The first one, thermal energy. Does anybody know what thermal might mean? Yes. Yeah. You're right. Thermal means heat. So go ahead and write the heat right there. Smart kids will write heat. Here's the question. Last night it got down to 40 degrees, right? 40 degrees. That was kind of cold. So you know what I did? I bet you did the same thing. I pulled the covers up over my head. And within about 2 minutes, I had some thermal energy going. Where did that heat come from? Most kids will say it came from the blanket. Where did the heat come when I pulled the blanket over my head? Yes. Let me give you a hint. Watch this. Here's my bed. If I put a rock in that bed, there's a rock, and I put a blanket over it, another blanket over it, that rock, let's say that rock was 50 degrees Fahrenheit. I come back in 1 hour. What's the temperature of that rock? This is a trick question. What's the temperature in 1 hour? What's the temperature of that rock? 1 hour later. Let me give you another hint. Before you answer, same bed, This time, I lay down in the bed. I put blankets over me, blankets over me, blankets over me. I come back in 1 hour. What's the temperature going to be? Now you have 3 choices. You could say the temperature stays the same. You can say the temperature will go down. You'll say the temperature will go up. Let's do this one first. What do you think is going to happen here in 1 hour? Show me, predict. You're right. The temperature will go up. After about an hour, it might be 90 degrees in there. What caused that to get hot?
The sun. Blanket.
Ah,
No,
yeah. Oh, so you mean that when you get a blanket out of the drawer, it's hot? It's not the sun. I'm inside the house.
Your
In the back, yes.
air.
Oh, so the air is hot?
The pressure. Your heater.
Yes. Yes. Myself. When you, right now, you're living, you're hot. You're 98 degrees or more. Guess what? When you put blankets on, the blankets don't make you hotter. The blankets trap the heat. So when I'm in here, watch. All my heat goes up and bounces back, and bounces back, and bounces back, and bounces. It's like a little oven. Let me give you one more hint. You were outside today. It's cold, colder. You put a coat on. Does the coat heat you up?
Yes. No. Sometimes.
No.
It collects the air. It traps the air.
Air from what?
From yourself.
From yourself. So the coat, if you put a coat outside by itself, it's going to be frozen cold. It's not going to be hot or cold. It's going to be what the temperature is. But a coat traps the air. So we are the heaters. We are the heaters. The food in my stomach is formed with thermal heat. So you might put under thermal heat digestion. When you digest things, when you eat things, okay, here's my hard question then. See if you get this right. I hope I'm trying to build some understanding in your brains. You put a rock, it's 50 degrees. You put it under covers. I'm almost afraid to answer this question. You come back in an hour, what's the temperature of that rock going to be? Class?
Same.
Same. Why? It's not living. It's a rock. Very good. This stays the same. You know, Mr. Ramsey has some snakes. They are cold-blooded. Now, I probably am wrong on this, but if you put a snake under here and you come back, it's still going to be 50 degrees. Snakes are
Cold.
But if that snake moves around, he can cause friction, and he might make it go up to 52 degrees. But you and I, we just lay in there, and because we have food in our bellies, through our cell respiration, we give off heat. So next time you get a coat, coats don't keep you, the coats don't generate heat. Unless you got an electric coat. Coats keep your heat from you in. So that's thermal heat. So I have some more thermal heat. Here's one. I hope I have it here. Here we go. Okay, so here is an example of thermal heat, right?
Don't play with matches.
I'm not playing with matches because it's a science class. And so now, you might want to, under thermal heat, you might want to draw a picture where it says thermal heat, draw a picture of a candle. And you know I can prove it. Ready? Watch. Oh, I can feel the heat. Oh, guess what? This is another example. You have to draw this twice. Mr. Ramsey, turn off the lights. And where else would you put this? And besides light energy. Find where it says light energy. So we have chemical energy, oatmeal. We have thermal energy, heat. Let's do another example of thermal energy. Remember I told you about that snake? Take your hands and go like this.
Oh yeah, friction.
Do it 150 miles an hour. No, stop. They'll catch fire.
Oh, really?
At 150 miles an hour, it'll start to ionize and you will catch fire. Yes. Well, yeah, you could. Don't believe me. Rub your, don't do that, no. Because your body goes, here's what's happening. You start doing this, your body's going to say this. Your body's going to go, that big dummy's trying to melt his hands. Here's what we're going to do. Send some juice down there. Send more juice, and you'll get a big blister. Your body tries to protect you by sending liquid there, and that's how you get the muscle. All right, stop for a second. Well, let's talk a little more about chemical energy. So chemical energy, this is the chemical energy we've used for hundreds of thousands of years. This is a piece of wood. Sun shone down, a tree starts to grow, it takes carbon dioxide out of the air and makes wood. We collect this, burn it, feels nice. Burn it, hey, I see everybody. So this gets transformed from sun to chemical wood to heat and light. Got it? So I'd put wood down under heat and light. And then people found a way to make it more efficient. I don't know who invented this. I wish I would have invented it. But if you start to burn wood and you take away the air, that sounds weird because you need three things to burn. You need a fuel, you need heat, and oxygen. But if you lower the oxygen, that wood doesn't burn all the way. It chars. And you've invented charcoal. Charcoal is a chemical energy source, potential. If I light this, how many people have had a cookout with charcoal? Okay, you only have to have a bag of charcoal. If you did that with wood, you'd have to have a big pile of wood. This is more energy. This is the same amount of energy as this. Now talk about energy transfer. The old candles and flames used to be made out of the fat of animals, and those used to be made out of the fat of whales. We used to, for a short period in this world, hunt whales, cut up their fat, their blubber, squeeze the oil out, and all over the world people used whale lamps to light their house. Luckily, they did away with that. Tell you, there's another form of energy. I'm not going to say it's good or bad. This is a fossil fuel also. This came from Indiana. Anybody know what this is?
Coal. Is it the
Coal. It's a rock. It's a sedimentary rock. It's a fossil. Look, you can see the tree bark. This used to be a swamp tree. If you look this up in the encyclopedia, you'll see this tree. It used to be 40 foot tall with this really cool bark on it. It takes, for this inch of coal, it took like 10 feet of dead trees squeezed down, swamp, plants, bugs, dragonflies, insects, squeezed down for 340 million years. So this is like a battery. This is like an Earth battery. Sunlight grew a forest. The forest got squeezed down, and this is buried 400 feet underneath Indiana. There are 7 layers of this. 4 of these layers don't burn very good. They're really stinky and not very thick. But 3 of the layers are thick enough for us to dig, break up, send to Indianapolis, and burn. We burn this. So coal is a chemical potential energy. Go ahead and write that. Potential energy, chemical, coal, C-O-A-L. If you don't believe me, watch this. And here, look, here's a piece of coal. Are you ready? Potential, chemical. Now look, when I was a kid, I lived in England. And my job every night was to go get coal, bring it in the house, put it in our stove. Like there's a rock that's burning, a burning rock. Now the thing what's good about this, you burn this and it gives off heat. The bad thing about this is it gives off, you should be able to smell some really bad flame and sulfuric acid. Yeah, but hey, we don't have to, you know why we don't have to worry about this? Because in Indiana the winds blow this way, so we burn all this coal, we don't have to worry about it. All that stink and pollution goes to Ohio. Is that okay?
No. I don't smell anything.
All right, so there's coal. Oh, so you're probably saying, Mr. Crosslin, why is this is chemical? So chemical energy, oatmeal, food, coal, charcoal, wood. You're going to see in a little bit, my friend, Mr. Jones has a special demonstration for you.
Oh, yeah.
This is so cool. I love this. Now, you know, I'm going to go next summer. I'm going to go in where the man who invented this lived. He wanted to be a scientist, but they wouldn't even let him be in the science group. So he got a job washing dishes. And he found, one day he said, let me show you something. He made a magnet. He put some wires inside of it. His name was Michael Faraday. And he discovered this. Watch. If I spin this wires inside of this big thick magnet,
That's cool.
this is cool. No, this is hot. This is cool. No, his name was Michael Faraday, and he found out that, now, guess what? Today, right now, the same thing's happening. You have somebody outside your house turning a crank, right?
No.
Have you seen that person out there doing it?
Yes.
No, you have. I'll tell you why. We have somebody that turns the crank for us. But just to prove this, I need a volunteer. This could be dangerous, though.
No, I'm ready for danger.
Okay, come on, you ready for danger?
Danger's pretty good.
Do you have good insurance? You have a good heart?
Yeah.
Got any money?
No.
I got money.
All right, here's the deal. Next week, we're going to, I don't expect you guys to know this, but next week, one of our lessons is electric circuit. And you're going to learn that you have a source of electricity. Luckily, I had that oatmeal in my belly. Mechanical energy converted, not destroyed, not created, but transferred to electrical energy. Go ahead and put your finger right there on that red.
Oh, no.
Watch out, man. Oh, you scared me. All right, go ahead. Am I the kind of guy that would electrocute you?
Excuse me.
Are you ready? You're brave, man. 1, 2, 3. Oh, you know what? This is not working. I was trying to send you a message, man. Oh, you know what? Most of the power is going through the light. I'm going to take the light out so you get all of it. Ready? Just one finger. One finger. You're very trusting. 1, 2, 3. See, not much of a load. I can do it easy, but what are you, Magneto or something? Wait, I know. Lick your finger because you're. I'm not going to lick it. You lick it. Okay, moisten your finger. The saliva in your mouth is salt, and that's a good conductor. Go on. Lick it just a little bit. Here we go. Oh, this is really going to get you. Okay, electric circuit. It has to have a source. It has to have a path. It has to go to the appliance. Oh, it has to come back. It's a circuit. Put your other finger. Put one finger there and lick that one. Now let's see. Do we have a complete circuit? Let me know. Look at them. And on the count of 3, I'll turn as you tell me if you feel anything. 1, 2. What? Your hair's a little curly right now. Now you're a good sport, but you know that all good scientists, that might have just been an accident. All good scientists always repeat the experiment twice. You want to try it?
No!
The guy in the back, you want to try it? You're pretty brave. What's your name? Okay, one finger there, one finger there. Are you ready? Wow, you must be like super conductor or something. Mr. Insulator Man. What's missing? What did we forget to do? Oh, the other thing here. Oh, so you do that. Right there, man. Watch it. Make me nervous. Look that way. Count to 3, and I'll do it. Go on. Look that way. Count to 3. Right there. You can.
Do it, Cameron.
Give him a round of applause. As you can see, I am not creating, I'm not destroying, I'm only Transferring in. So make on your electrical energy. Is electrical one of them? Draw a light bulb. This is one more example of potential chemical energy. Now, quiet please. So I have here an iron cannonball that's really dangerous because if I don't want to drop it, because it's pretty. These things are really heavy. And I have a piece. These are rusty and have aluminum. So if I can add rust plus aluminum, I can get a really good thermal energy reaction. Ready? Watch. This is so dangerous. So you gotta be careful.
No. Don't do it.
Ready? Yeah, it's a glancing blow. Rule number 1, don't get hurt me.
Oops,
Rule number 2, don't get hurt me. Rule number 3, don't get hurt me. Ready?
2, 1, go.
That's cool. Ready? Hey, too much sound energy. Okay, so, come here, my friend. This kid, here you go. Now, rule number 1, don't hurt me. Don't hurt me. Rule number 3, don't hurt me. Now, you know what you do. I'm not. Quiet, please. It's a glancing blow. Do it again. Let's give her some sound energy. Good job. This has been an example of potential chemical energy. We've had oatmeal, we've had coal, wood, charcoal, and another chemical reaction. So let's look at another form of energy. And this form of energy you've actually been hearing all along. It's sound energy. So you can put down your paper, voice or talking is an example of sound energy. So is vibration. In 3rd grade, we did a big unit on sound is vibration. Remember we did?
Yes.
Sound is vibration. Here is something I can make sound. Check this out. Listen. And then this one is a little bit longer. And I put them together, they harmonize, the two sounds combined. So you have, that's not good. Sound energy can be really deafening. In fact, scientists are finding ways now to use sound energy to do things like put out fires. Or sound energy to stop people from attacking. They can send sound waves that make you stop and feel sick, like loud noise like this. It sounds like a seal. And so we learned that it takes transfer from movement. This is a peepa or a frog, and that's one sound. And as you expect, when it's a smaller, so you might write frog as an example of sound energy. And my favorite one, though, is this guy right here. So let me get my hands really dry.
What?
Remember this in 3rd grade?
Yes.
So you have to be quiet.
That one's squeaky.
Okay, I'm going to get this really dry.
Uh-oh.
And if I can get it to vibrate, I can get it to make a sound. But I never hear it. I'm old, so I don't hear this sound. But maybe you guys can. Listen quietly. And I'll probably go like, if I go like that, you grab it and stop it from vibrating. Okay, practice. Thank you. Practice. Thank you. Okay, you ready? Quiet on the sets. Oh, you hear something?
Yes.
How was that hurting?
Stop it.
let me try this one.
No, don't do it.
There we go, ready? You hear it? Ready?
Stop it.
See, when he grabs it, it stops vibrating. So sound energy is transferred through the air. Oh. Not bad. Sound energy. Okay, draw that real quick. I call this the singing rod or the vibrating rod. Let's look at some potential energy, gravity. Some gravitational potential energy or some elastic. Let's do the gravity one first. Ready? Here we go. Here is no energy. I lift it up. Gravity wants to pull it back down. So I've given it potential energy. Everybody say no energy.
No energy.
Potential energy.
Potential energy.
And then kinetic energy when it moves. So you can see gravity is pulling it down. This is an example of motion, which is kinetic energy.
It's like
No energy. Potential energy.
That looks fun. I wish I was that ball.
Kinetic energy.
you've been having fun.
Yes.
Try it one more time. No energy. Potential energy. Kinetic energy.
I wish I could.
So, now we can also talk, so on your gravitational energy, draw a picture of this falling down. Let's look at elastic energy. Check it out. No energy. This is elastic energy. No energy.
Oh, I know this.
3, 2, 1.
It's like a cricket and a spider together. It's breakdance.
No energy.
Breakdance. Come on, breakdance.
Shake that. Breakdance.
Quiet, please. No energy. 3, 2, 1. Kinetic energy. No energy. Elastic potential energy. Run out of energy, man. There we go. I guess one of my favorites is this. Okay. So let's talk about that elastic potential energy, okay? Here, hold this for a second. Stand up for a second.
I want to see your
Yes.
magical assistant.
Yes, my science assistant. Now, so this is no energy, right? Hold that. Pull it. This is elastic. Pull
Oh,
it.
it's wonderful.
Pull it. On the count of 3.
No.
What? No energy.
Let go of it on the count.
Pull on the count of 3. Wise guy. That. This is potential elastic. Come on, stretch it. Potential elastic, and on the count of 3, let go, and we'll show them kinetic energy. All right? Wait a minute. I didn't count it. No energy, right? No energy. Everybody say no energy.
No energy.
Potential elastic energy. On the count of,
Elastic energy.
when I count to 3, you let go, and we'll see kinetic energy. Ready? On 3. 1, 2. Okay. I got this.
You tricked him.
Alright. That's fair. That's fair.
What he says.
No energy.
No energy.
Potential elastic energy. 1, 2, 3. No energy. Say it. No energy. No energy.
Come on,
Potential energy. One more. Now this has a lot of potential energy. No energy, potential energy, and 3, 2, 1. Kinetic kinetic energy. All right, I'm going to end this. I'm going to end our lesson. If you would, I would like you to have drawn on that balloon. Here's the balloon with no energy. Okay? This is potential, elastic energy, no energy. Here's the balloon with a lot of energy. This is potential energy. And here's the balloon flying all over the room with kinetic energy. Good. So one more thing. Mr. Ramsey, I've been working out, man. Trying to impress my wife and my muscles. So I have my potential kinetic energy workout machine. Ready? You guys have to help me. If I can bend this, I want to hear it. Okay, ready? No energy. Everybody say no energy.
No energy.
Of course he can bend that. Potential energy. Potential energy. 1, 2, 3. Kinetic energy. So that's kinetic energy. Ooh, potential. Kinetic. Here we go. No energy. Ready? Say no energy.
No energy.
1, 2, 3.
Kinetic energy.
Potential. 1, 2, 3. Kinetic. Don't you stand up, Mr. Ramsey? And here we go. I'm going to send, most of the time,
Over this way a little bit,
Albert
Mr. Ramsey.
Einstein studied how things move.
Great,
so I
right
thought we
there.
might study how Albert Einstein moves, okay? Here we go. Ready? No energy.
No energy.
Ooh. Where's the ooh, guys? Come on.
Oh no.
2, 1. Kinetic energy, Albert. Give me a round of applause. Thank you very much. There are lots of forms of energy, but everybody repeat after me. You cannot create energy. You cannot destroy energy.